Welcome all. Now I am going to discuss question number 50 from the GATE 2019 paper Electrical Engineering. The question is, a 30 kV 50 Hz 50 MVA generator has the positive, negative and zero sequence reactances of 0.25 per unit, 0.15 per unit and 0.05 per unit respectively. The neutral of the generator is grounded with a reactance so that the fault current for a bolted LG fault and that of a bolted three-phase fault at the generator terminal are equal. The value of the grounding reactance in ohms. To know the detailed modeling of the symmetrical and unsymmetrical faults, it is advised to go through the given NPTEL video link. Let us have a brief discussion on the single phase and three phase fault. Since the single phase fault is a unsymmetrical fault, the fault current have positive, negative and zero sequence components. From the equivalent diagram of single phase fault, one can say that positive, negative and zero sequence component of fault currents are equal and the fault current is given by Vf by Z zero sequence reactance plus positive sequence reactance plus negative sequence reactance plus 3 times of the reactance that is connected between the neutral and the ground. Now coming to the three-phase fault. Since the three-phase fault is symmetrical, it will have only positive sequence component of fault current which is given by terminal voltage by positive sequence reactance. Now let us solve the problem. Given generator specifications. Given data is voltage rating V is equal to 30 kV, frequency is 50 Hz and the MVA rating, apparent power rating of the generator is 50 MVA. And also it is given that the positive sequence reactance in per unit, that is 0.25, negative sequence reactance is 0.15 and the zero sequence reactance is 0.05. And also it is given that a reactance is connected between neutral and ground. Neutral and ground. Such that the single phase fault current is equal to the three phase fault current. Single phase fault current is equal to the three phase fault current. So as we have discussed previously, single phase fault current is unsymmetrical, which is given by terminal voltage across the generator divided by positive sequence reactance plus negative sequence reactance plus zero sequence reactance plus 3 times of the reactance that is connected between neutral and ground. This is single phase fault. And also we know that three phase fault is symmetrical, right? Which is given by terminal voltage by only positive sequence reactance. And it is mentioned that single phase current is equal to the three phase fault current. If we substitute, since reactances are in per unit, we will take terminal voltage also in per unit value. That is 1 divided by 0.25 plus 0.15 plus 0 sequence, it is 0.05 plus 3 times of xn. This xn value we need to find. Pt by x1 is 0.25 per unit. If we simplify this expression, we will get xn as 0.1 per unit. But in the question, it is asked to find out the reactance value, not per unit value. So we need to find out. So we need to convert this reactance value, per unit value, to reactance value. So we need to find the Z base. Z base is given by kV square by MVE. So kV it is 30. 30 square by 50. That is equal to 18 ohms. So X absolute value is equal to X per unit value into Z base. X per unit value already we got it as 0.1 into Z base it is 18 ohms. So 1.8 ohms. So the actual value of the actual or absolute. Actual or absolute of the reactance is 1.8 ohms. So the value of the grounding reactance in ohms is 1.8. Thank you.